Hey everyone, welcome to my channel. Today we are going to discuss about the array data structure. So array is the most important concept of data structure because if you understand what is meant by array, then it is much easier to understand the other types of data structure. So this is the very important topic of the data structure, and today we are going to discuss about what is meant by array, the syntax of array, how to represent array in a memory, and the types of array, and so on. So let's start from what is meant by array. So array is a collection of elements or items of the same variable type that are stored at the continuous memory locations, meaning that there are the number of elements which are stored in an array and all the elements are of same type. Same type means same data type, and these elements are stored in a continuous memory locations. So array is a linear type of data structure. In the previous lecture we already discussed about the types of data structure. Linear data structure means the elements or items are stored in a continuous memory locations. That's why it is called as a linear. Now let's see the syntax of array. So the first thing is a data type, then the array name or the name of array, and then in square bracket size of array, end with semicolon. So this is the syntax of array. First is a data type, then array name, and then size of array. Let's see an example. For example, data type is an integer, name of array is a, and size of array is, for example, 5. So here integer is a data type, then a is an array name, and 5 is a size of array. Array size can always be declared inside the square bracket. So here we can say that 5 elements are stored in an array A which is of type integer. So all the elements of array, that is 5 elements, are of same type, that is a integer. So we can say that it is a collection of items or elements of the same type, and these elements are stored in a continuous memory locations. And that's why array is called as a linear data structure. Okay, let's see how to represent array in a memory. So first, as we see, integer a of 5. Here 5 elements are stored in an array of type integer. Suppose here we have array elements like 2, 6, 8, 13 and 15. Let's say for example, so here we declare the array elements. Integer a of 5, integer is a data type, a is an array name, 5 is the size of array, equal to, in curly bracket we declare all the elements of array, that is 5 elements of array, for example 2, 6, 8, 13 and 15. Now let's see how to represent these elements into the memory. So this is the representation of array in a memory. Our first element is 2, then 6, 8, 13 and then 15. So these are the elements of array. Elements, or we can say that items of array. Okay, A is an array which is of size 5 and all the elements are of type integer. Now here array index start with 0. That means 2 has the index value 0, 6 has index value 1, then here is a 2, 3 and 4. Okay, so array index always start from 0. So the first element is at 0, then 1, 2, 3 and the last element index value is 4. From this we can also calculate the lower bound and upper bound of the array. Now what is meant by lower bound? Lower bound means the starting index of array, and upper bound is the last index of array. Now in this example, the lower bound, that means the starting index of the array is 0, and in the same example the upper bound means the last index of array is 4. So whenever we learn about the algorithms, then we have to know about what is meant by lower bound and what is upper bound. So lower bound is the starting index of the array and upper bound is the last index of the array. For example, if we have 10 number of elements in an array, all are of type, for example, integer, then the lower bound, that is equal to 0, because the array index always start with 0, and the upper bound is equal to 9, means the last index of array is 9. So in this way we can calculate the lower bound and upper bound of the array. Now in this example, suppose we have to get the element or we have to initialize the element, then the second method is, for example, a of 0 that is equal to 2, then a of 1 that is equal to 6, a of 2 is equal to 8, a of 3 is equal to 13, and a of 4 that is equal to 15. So this is the second method we can declare or we can initialize the array elements, or this is a one method we can initialize the array elements. So you can use any one of the method from the above, the first or second one. This is a logical representation of array in a memory. So here A is an array, 2, 6, 8, 13 and 15 are the elements or items of the array. Here we also have to know about the lower bound and upper bound of array. Lower bound is the starting index of array and upper bound is the last index of array. Now array has a fixed size. That means here we declare the array as integer a of 5. That means we can only store the 5 number of elements in an array. We are not allowed to store the 6th element because the size of array is fixed. So array size is defined while initializing the array. Now there are two most important terminologies regarding array. The first one is a element, or we can say that item, and the second one is a index. So what is meant by element and what is index? So first, what is element? Each item that is stored in an array is called as a element. Each item that is stored in an array is called as a element. For example, in this example, the elements are 2, 6, 8, 13 and 15. These are the elements, or we can say that items. And what is index? Memory locations of an element in an array. So index is a memory location of each element in an array, and as we know, the array index always start with 0, and from the array index we calculate the lower bound and upper bound of array. Now there is one more thing regarding array, that is calculating the size of array. Suppose we have to calculate the size of array. So there is a one formula to calculate the size of array, and that is upper bound minus lower bound plus 1. So for example, if we have an array that is integer a of 5, that means the lower bound is equal to 0 because the array index start with 0, and upper bound is equal to 4 because array index start with 0, so the last element is at 4. So here upper bound is equal to 4 minus lower bound, that is 0, and plus 1. So here 4 plus 1, and that is equal to 5. So in this way we can calculate the size of array. Always remember the formula, upper bound minus lower bound plus 1, or you can say that lower bound minus upper bound plus 1.